Good morning, everyone. I am Rajeshwari Pawar, and my teammates are Rushali Koli, Rupali Tawar, and Archana Kot. Our topic is differential thermal analysis, and it is guided by Dr. Vijaya Berge ma'am. Now, see the contents. Introduction to thermal method of analysis, introduction to DTA, principle of DTA, instrumentation, advantages, disadvantages, pharmaceutical application, derivative differential thermal analysis. Now see introduction. When matter is heated, it undergoes certain physical and chemical changes. The physical and chemical changes sample undergoes when heated are characteristics of material being examined. Definition. The term thermal analysis, those techniques in which some physical parameter of system is determined or recorded as a function of temperature. There are three types of thermal analysis technique. First one is thermogravimetric analysis, second one is differential thermal analysis, and third one is differential scanning calorimetry. Now see differential thermal analysis. DTA is an analytical technique for identifying and quantitatively analyzing chemical composition of substance by thermal behavior of sample as it is heated. The technique is based on fact that as a substance heated, it undergoes reaction and phase changes that involve absorption or emission of heat. DTA curve. The endothermic reaction shows downward peak. It means absorption of heat. Exothermic reaction shows upward peak. It shows the emission of heat. The size and shape of peak gives good information about nature of test sample. This is diagrammatic presentation of the thermogram. Now see principle. The technique which temperature difference between substance and reference material is measured as a function of temperature while substance and reference are subjected to controlled temperature program. The difference in temperature is called as differential temperature is plotted against temperature as or function of time. Physical changes usually result in endothermic peak, whereas chemical reactions, those of oxidative nature, are exothermic. Endothermic reaction shows downward peak, and exothermic reaction shows upward peak. This is diagrammatic presentation of the DTA instrumentation. Now see instrumentation. First furnace, second sample holder, third is DC amplifier, fourth one is difference temperature detector, fifth one is furnace temperature programmer, sixth one is recorder, and seventh is control equipment. First one, sample holder. One should be very careful while selecting the material for fabrication of sample holder. Both metallic as well as non-metallic material are employed for fabrication of sample holders. Metallic holder gives rise to sharp exotherm and flat endotherms. Non-metallic holder gives rise to sharp endotherm and flat exotherms. Now see furnace. Furnace possesses characteristics for good temperature regulation and programming. These are fairly inexpensive. Third, temperature control and recorder. First one, temperature control. Three basic elements are required. These are sensor, control element, and heater. There are two methods for controlling temperature, which are as follows. First one is on-off control and second one is proportional control. Then B, recorder. In thermoanalytical studies, the signal obtained from sensor can be recorded, in which signal stress is produced on paper or film by ink, heating stylus, electric writing, or optical beam. Now see advantages. First one is instrument can be used at very high temperature. Second one, instruments are highly sensitive. Third one is characteristics transitions or reaction temperature can be accurately determined. Then disadvantages. First one is uncertainty of heat of fusion transitions or reactions estimation in 20 to 50%. Second one is sharp thermal changes are unable to predict. And third one is precision not good. There are some pharmaceutical application of DTA are as follows. First one is DTA is widely used in pharmaceutical and food industry. Second one, it is used to determine the purity of substance. Third one is it is used in a cement and glass industry. Fourth one is DTA is used to identification of substance. Fifth one is it is widely used to study physical properties of substance such as melting point, boiling point, and effect of heat. Sixth one is it is used for determination of exothermic and endothermic nature of substance. Now see the last point, derivative differential thermal analysis. A method based on use of two temperature of the inflection determined on a single derivative differential thermal analysis DDTA curve and of the temperature of the extremum determined on the differential thermal analysis DTA curve is proposed for computing the activation energy and the order of reaction of chemical process. The obtained formula do not contain the heating rate. If the conversion degree corresponding to the three temperature required by the formula are known, the third kinetic parameter may be also computed. The formula are fitted to the reaction order model.